And then I wanted to just mention that there is in Matlab a package called BERTools. And BERTools is specifically designed to help you with this quandary about when should I stop, how many trials should I run. So Matlab in this package, it manages sweeps of BER. So you want to get some curve, you want to vary SNR, you want to vary some parameter and see how the bit error rate changes with this parameter. So you want to sweep through it. And there'll be some regions where your BER curve could typically span from 10 to the minus 2 to 10 to the minus 6. This would be a typical span for a bit error rate. Maybe you want to have a good computer and you want to go 10 to the minus 8 or something. But anyway, you're going through many decades of bit error rate. And you don't know in the beginning where you are or how many it's going to take. So what BERTools does is it just helps you sort of manage these decisions about how to do it. And what it does is it starts with a block size. And it's a block size that corresponds to sort of the smallest set of bits to be tested. So you say, I'm going to try 10,000 bits at a time. I'm going to run 10,000 bits, and I'm going to see if I get any errors. And if I don't get any errors, well, I'll start iterating. Iterates to get more errors. So if you choose your block size too large, you're going to do a whole lot of computing power to measure 10 to the minus 2 when you don't need to. You're going to measure 100th of those are an error, and so if the block size is really big, then you're getting many more error counts than you need to get a good estimate of that bit error rate. But if you would choose it too small, then you're doing this sort of for loop, which is really, really inefficient in Matlab especially, where you're just running the routine too often. There are too many iterations, and it would be more efficient to have a larger block size. All BERTtool does is just gives you an easy forum for making these decisions and changing them and managing them. And you can always have an absolute stopping criteria, which means, this much time goes by, just stop my simulation. So the other day in Professor Yan's class, you talked about using OptiSystem, but it actually used BERTools to handle the calculation done by OptiSystem. So BERTools managed this decision about what size of block to generate in OptiSystem and how to do the sweeping and the iterating and to make sure that we've counted enough errors. So that this management of the Monte Carlo techniques was moved outside of OptiSim. And I didn't do it for the homework. I probably was to include BERTools in the simulation of the Monte Carlo. The idea, I just want to let you know that this tool exists and that you'll probably be seeing it elsewhere in the class. But it's all related to this theory about what is a reasonable number of errors. But you can always tweak that even using BERTools, whether you want to count at least 10 errors, if you're willing to go to 100 or whatever you want to step through.